Hello everyone, in this video we are going to discuss the solution for heaters problem. Okay, so let's see how we can do this. Alright, so coming to the question, what we need to do is first study our question. So in this question it is said that winter is coming. During the contest your first job is to design a standard heater with a fixed warm radius to warm all the houses. Okay, every house can be warmed as long as the house is in the heater's given range. So what we have been given is that we have some arrays called houses array and heaters array. The houses array, what does this houses array store? The address of the houses on a horizontal line. So let's suppose that this is a road. All right, and on this road there are some houses, and this houses array is storing the house number, house number 2, house number 3, house number 4, house number 9, house number 11, which is present in my houses array. It is containing nothing but house numbers. Alright, now I have heaters array, and heaters array is storing something similar to that. Heater array is contains at which position on the road heater is kept. Okay, heater number. So at one position one heater is kept, and in 8 position one heater is there, and on 5 position there is one heater there. Okay, so this is my road. On this road there are indexes or the number plot numbers, and in these plot numbers there are some houses and there are some heaters and some empty plots. Okay, now what I need to do is I need to design these heaters such that the heat from these heaters are given to all the houses on this horizontal road. Okay, so for example, let's say this house, yeah, house number 2. If I design my heater such that this has a radius of 11, meaning that this heater can give its warmth to the 11 indexes or the 11 plots again uh, on the right side and 11 on the left side. So won't it be very efficient? No, it won't be very efficient, because if I design such kind of heater that radiates heat to such extreme lengths, then this house is going to get burned, right? Because if heat is traveling to such distance, the people living in house 2, house 3 will definitely feel some heat. So we should not design something like this which is radiating a lot of heat. Also, in the question we have been given, we have to design some standard heater with minimum radius. Okay, because one is this reason, one is that the question in which we are doing says so, right? So I need to keep the distance of keep the radius of these heaters as low as possible, but it should be able to cover all the houses. So for example, this heater should be able to heat all these houses. This heater should be able to all the houses. This heater should be able to all the houses. All the houses. Does this question say something like this? No, it doesn't say that. This in this question, it is said that every house can be warmed as long the house is in the heater's warm radius range, meaning that even if there is only one heater present and its range is covering entire house, then it is warm. It doesn't matter if the house is covered with two heaters. For example, if let's say my range is 5, this is going to give warmth till 6th index, and this 5th heater is going to give heat till the 0th index if they was present. Okay, so something like this. And this house is these three houses are covered by the radius of three these two heaters. But let's say if I don't have this heater, then also I am able to cover the all the houses because my radius was 5. Okay, so it is said that even if there is only one heater, it should be able to heat the houses, all the houses. Okay, so this is what we have been given in the question. Now we need to figure out how we can minimize the radius of these heaters. Okay, the position of the houses and the heaters are fixed, and we need to find the minimum radius. So how we can find it? One thing we can do is we can try to find the distance of heaters from each house, distance of heater on the left side and distance from right side, which is the nearest heater. So for house 2, this is my heater which is closest on the left side, and this is the heater which is closest from the right side. So this distance is 1 and this distance is 3. Likewise, if I need to warm this house, if this heater was not present, only this heater was present, it will be able to warm this house. So this can warm the house, this heater can warm the house if its range is to 1. Alright, now we will see the distance of heater from this house. From left side it is 2, right side it is 2. Now it doesn't matter from where which heater I am choosing. If their range is 2, it will cover this house number 3. Okay, so 1 should not be my minimum radius, 2 should be my minimum radius. Okay, now I will check with 4. This is my heater which is closest from the left side, this is the heater that is closest from the right side. So this distance is 1 and this distance is 3. This distance can warm the house 4. Okay, but you can see that if I choose the distance 2, then only I will be able to cover this house 3. Okay, so this was all for these 3 houses. Now I have found that at least 2 radius should be present so that all these 3 houses can be warmed with these 2 heaters that are present at position 1 and position 5. Now if we will look at our 9th house, this heater, one heater is present on the left side, but there is no heater present on the right side. So there is no heater present. So if I will try to say some heater is present or not, it will mean that the heater is kept at the distance of infinity. Okay, so we are not going to consider anything that is on the right side for this. Okay, so distance, minimum distance from this house should be 1. Okay, now coming to my last house, the nearest heater is this heater number 8, or the heater that is kept at position 8, and the distance is at least 3, and there is no heater on the right side. So to keep this 11th house warm, what I need is the range of this heater number 8 should be at least 3. If the heater's range is at least 3, then only the 11th house can be warmed. So the minimum radius standard for all heaters should be 3, so that all the houses can be covered when the heaters are present at position 1, 5, 8, and the houses are at 3, 9, 2, 4, and 11 places. Okay, so that's how we are finding the minimum radius. Okay, so let's try to form an approach so that we can solve this question. All right, so have you seen something similar right now? What we are trying to do, we were trying to find the minimum distance of heater with the house, which is the minimum distance from left side and the right side from the heater. Okay, I found one here. For 3 it was 2, for 4 it was 1, for 9 it was 1, for 11 it was 3. I found the minimum distance from which the heater is kept at one house and tried to see which is the farthest house with the maximum distance, and that maximum distance was my minimum radius standard for heater. Okay, so if you look carefully, aren't we trying to find C floor and C from the house numbers, and from where we are trying to find floor and C from the heaters array? Okay, so we are doing something like that. So what we can do is, first of all, we if we are trying to find floor and seal from a array, it is better to have a sorted array. So first thing we are going to do is sort the heaters array. So I have sorted this array. Well, as given in the question, the heaters array is of size m, something like this. Okay, you can see the snippet of the program. Heaters uh, length of the heaters array is something m. So if I'm going to sort a array with size m, average time complexity to do this will be m log m, right? So this is how I'm going to sort my array of heaters. Okay, so now I have understood the question. Now let's move it down and try to okay, thing is wrong here. Well, it doesn't matter now. Okay, so this was my heaters array, this was my houses array. What I did was sort this, and it became 1 5 8. And how much time did it take? M log m. All right, so this much time it take to sort the array. Now what I'm going to do, I'm going to go from one house to other and find the floor. So let's find it. For 3, let's write it floor C, and then we are going to calculate distance from left side and distance from right side. Distance from what? Distance of heater and the house. Heater and distance between the house and the heater. Okay, so for C, my floor will be 1 and seal will be 5. Floor 1, seal 5. If I will calculate my distance from left, it will be 3 minus 1, 2. Okay, for my right side, sorry, this should be R. So distance from the right side will be 5 minus 3, which will be 2. So minimum from this is nothing but minimum distance of house from the heater is 2. Okay, now I'm at the position 9. Need to find floor. I will find 8. And distance from the left will be 9 minus 8 equal 1. Okay, now this is something interesting. Now I don't have any seal here. So what I'm going to do? If this was the case, I will say that I will return minus 1. And distance from the right, I will say it will be infinite. Because there is no possible distance from the right side now. Okay, so minimum distance between 1 and infinite will be 1. Now I'm checking for my house 2. So floor will be 1, seal will be 5. Floor will be 1, seal will be 5. And distance from the left will be 2 minus 1, which is 1. And 5 minus 1 equal 4. Alright. Sorry, 5 minus 2. Okay. So minimum distance between 1 and 3 is 1. And now for 4, my floor will be 1, seal will be 5. 1 and 5. Distance from left will be 4 minus 1, which is 3. And distance from the right will be 5 minus 4 equal 1. 1 is minimum distance. Okay. Now I am at the last house, 11th house. Floor will be 8. Seal will be minus 1 because there is no possible answer here. You remember the houses now? It was like this. Okay, now let me remove this. Something like this. This is my 11th house. There's nothing in here. So I'll say distance from the right will be infinite. Although infinite is not written, but I will just assume that it will be infinite. Okay, so distance from the left should be 11 minus 8, which is 3. So minimum distance is 3. And among these minimum distances, I will try to find the largest distance so that all the heaters, all the houses are warmed. So this is what I'm going to do now. First, I'm going to sort what? My heaters array. This array. Okay. After this, I'm just going to travel all over my house numbers. I try to find floor and seal using binary search. Binary search on what? Heaters array and try to find floor and seal. And then just try to calculate distance from left, distance from right. And I will try to find the minimum distance from which the heater is present from that house. Okay, and I will find the minimum distance, and among these minimum distances from all the houses, I will try to find what I'm trying to find, the maximum distance, so that I can create a standard. I can create standard what? Minimum radius standard of all heater, because all heaters are going to have the same radius for heat. Okay, in that radius all the houses will be warmed. All right, now just we are going to code this, and then we will discuss its time complexity. Okay, so let's see how we can do this. All right, then let's code this. So first thing we were going to do is we are going to sort our heaters array. So for that I'm going to use sort heaters dot begin and heaters dot end. After this, what I need to do is calculate a on radius. So my answer radius I need to calculate. Okay, now what we were doing in the question was we were trying to travel for each and every house and try to find floor and sea. The floor will represent my nearest heater from the left side and sea will represent the nearest heater from the right side. Okay, so let's travel on my houses. I equal to 0, I less than houses dot size. Okay, I plus plus, that's it. Now what we need to do is calculate seal and floor. And how we are doing that? We were trying to do that by using a binary search algorithm. So let's write a pair should be of integer which is representing floor and our integer representing our seal value. So let's name it p. All right, now I will call a binary search algorithm. This is my binary search. Binary search will work on heaters, and by using what parameter it is going to search my floor and seal? My house number. So house number is nothing but houses I. Alright, so after this I will get some floor and some seal. Now I need to calculate the distance from the left side heater and the right side heater. Okay, so let's calculate for the left side. Int d1 equals to it will be houses I minus p dot first, because I will store the floor in the first part of the pair, and int d2 equal houses I and p dot second. Okay, so this is how we are going to calculate the distance, but is it right? Is it possible that every time I try to find heater on the left side I will find it, or I will find heater on the right side? Is it possible? Let's see. Here, can you see? Is there any heater on the right side? No, there is no heater on the right side. So what is going to happen in this case? I can say that if there is no heater on the right side, the heater should be present at infinite distance. I can say that. Okay, and there is only heater on the left side. So when I will be bringing my pair which is representing floor and seal value, I will put -1 in that, so that I will not try to use this distance. Okay, now let's put a check here. P dot first not if this equals to -1, then the heater is present at infinite. Okay, you can put any value here, but be sure that this value is much bigger than my distance, the actual distance, that is the d1. Okay, d1 or d2, much bigger than that. Now same check here, p dot second, and there's no heater on the right side. So if this is equal to -1, then also 1e9. Be sure to put this 1e9 if there is no alternative heater present for left side or the right side. Right, now what we were doing, we were trying to find the heater which is taking the minimum radius for this house. So minimum min d1 comma d2, and if this minimum distance is more than the answer distance, replace answer distance with minimum distance that I have discovered here for the house. Okay, so that's it. After this we are going to return the answer distance. So we are done. No, we are not done. We need to write the search binary search algorithm. So let's write that also. And what this binary search algorithm is going to return, it is going to return a pair of int comma int and binary search, and this is nothing but vector of int, vector int, and my house number. So let's name it hn. All right, so we are doing a binary search, so what we need is a low, high, and high will be equal to heaters dot size -1. That's it. We have low and high. Now we need a pair int int. Let's name it answer also. Answer, make pair, because in the starting we need some value, and I will put -1 in both of the cases because I was checking if there is no heater on the left side or no heater on the right side, there should be some condition, so I have put it here. Now I just need to write the binary search, low less than equal to high. That's it. And after a while I need to return pair. Okay, so this is what we are going to do. We need to calculate the mid. Will be, this will be equal to low plus high divided by 2, and I need to check now if mid equals to house number. If this is true, then it means the answer dot first and answer dot second, meaning the left side the floor and the seal is the same because the heater is present inside the house. Okay, so distance is going to be 0. So for that, what I need to do is put answer dot first as the house number and answer dot second also as house number, then just break the loop. Okay, else if mid less than house number, it means that I have found a heater that is on the left side. Okay, the nearest heater that till now I have figured out that one heater is present on the left side. So what I will do is put answer dot first as the mid, and now I will update my low as mid plus 1 because now I have found a heater on the left side. Now I will try to say if there is a heater that is on the left side but much near to the heat house. Okay, and same case here, if I found heater on the right side, I will just do the same thing. Instead of first, what I will do, I will write second. This is representing the C value. Okay, and same. Now I have found a heater on the right side. I will try to check if there is also a heater which is much near on the right side. So for that, mid -1, and that's it. Okay, so this is the code for the binary search. But tell me, have I written the right code? See this binary search carefully and try to figure out where I have made a mistake, because I definitely have made a mistake here, and that too deliberately. So pause video here and try to see where I have made mistake. Okay, so I think you have tried to figure it out, and you may have figured it out. Even if you don't, I will just tell you, because I have to show you the correct code. So this mid is representing the middle index of the heaters array. It is representing what? Mid of heaters array. This is representing the index, okay, not the position of the heater. So for position of heater, I will need to write heaters dot mid, heaters bracket mid. Here I'm just storing the house number, so there is not a problem here. But here I will need to do the same thing, and here too, where I have put just mid, I will have to update it as heaters mid, because it is the index. Okay, so that's it. I think we are done with the code. Let's run it. So there is some mistake. 18, 26, return pair. Okay, I have made mistake I was doing for the answer. So let's run it now. Still some mistake. I have missed the T in the sort. Still some mistake. I have made a lot of mistakes. 36, 36. Let's name as M, because min is used as a function, and now it is accepted for a sample test case. Let's submit it. Alright, so we got 10 out of 10, which means our code is correct. Right. So let's talk about its time complexity. Now here's the code. This is the code for binary search. This is my binary search. How much time it will take? It will take log n time, or in this case log m, because number of heater is m. I should write it here. Number of houses is n, and number of heater is m. Okay, so log m time it will take, and also to sort the heaters array it will take m log m time. And for this loop, this first thing is running in n, and I'm calling a binary search inside it, so n log m time it will take. Now whichever from m log m or n log m is bigger, this is going to give the time complexity for my entire find radius function. So my time complexity could be m log m or n log m. Whichever is the bigger value, this will be my time complexity. And what about space complexity? Have I used any additional array or any other thing? No, I haven't used any other array or anything like that. So the space complexity will be constant. So that's it. What we did in the question was simply try to visualize the question. Okay, this was a very difficult problem when we were trying to just read it and try to solve it mentally. But when we tried to visualize it using this, what we figured out was that it wasn't that difficult as it's supposed to be. Okay, it was a very simple problem. It was just that we were not able to visualize it mentally. So we tried to draw it. So my tip for you in next questions will be that you try to visualize the questions, and after visualizing it, try to figure out a way. And I'm definitely sure that you will be able to figure a solution by yourself. So that's it for the solution of the heaters problem, and I will see you in the next question. All right, so till then, take care and goodbye.